If you think about a parabola U-shaped graph intersecting the x-axis, it may intersect the x-axis in three different situations. It may cross through the x-axis, turn and come through again. That would be two solutions. Remember, when it hits the x-axis, that is a solution to that quadratic equation. So it may pass through the x-axis, turn and come through again. That's two solutions. It may just touch the x-axis, turn and go the other way. That's one solution. And it doesn't matter if it opens up or opens down. Also, you may have no solution, where it hovers above or below the x-axis, not intersecting at all. That would be no real solution. There are what's called imaginary solutions. So you may have two solutions, one solution, or no real solutions. That would in fact be two imaginary solutions. So a quadratic equation could have two solutions. An example of that would be x squared equals 4. If you take the square root of each side, you'd end up with x equals 2 or negative 2. You can see that quadratic equation has two solutions. It may have one real solution, where if you have x squared equals 0 and you take the square root of each side there, x would equal 0. That's one solution. Or it may have no real solutions, where you have x squared equals negative 9. Now think about this. If you take the square root of each side, the square root of x squared is x. But taking the square root of negative 9, it's not going to happen. You're going to get into what are called imaginary numbers, and we're not quite there yet in our discussion. So that would be no real solutions. So you may have two real solutions, one real solution, or no real solutions. This last case would actually be two imaginary solutions. In the quadratic formula, the value under the radical sign, this b squared minus 4ac, will tell you how many real number solutions exist. That b squared minus 4ac, that part under the square root sign of the quadratic formula, that's called the discriminant. The discriminant of a quadratic equation in the form of ax squared plus bx plus c equals 0 is the value of b squared minus 4ac. So think about your quadratic formula. That b squared minus 4ac under the square root sign, that is the discriminant. And that reveals or tells how many and what type of solutions you'll have. So once again, make it clear, b squared minus 4ac, the part under the square root sign of the quadratic formula, that is called the discriminant. We're going to take a look at the value of the discriminant and how it reveals the solutions to quadratic equations, the number and type of solutions to quadratic equations. If that b squared minus 4ac, if that part under the square root sign is positive, if it's greater than 0, that means there are two real solutions. That means the parabola would hit the x-axis in two places. If the discriminant, the b squared minus 4ac, is equal to 0, that's where the parabola just touches the x-axis, turns, and goes the other way. Think about the quadratic formula. If you had negative b plus or minus the square root, and if that was 0, then that plus or minus the square root of 0 wouldn't matter. It'd just be negative b all over 2a. So if b squared minus 4ac is equal to 0, there's just one real solution, or one x-intercept. And finally, if that b squared minus 4ac is less than 0, if it's negative, if the part under the square root sign of the quadratic formula is negative, that means there are no real solutions, which would actually be here two imaginary solutions. So that parabola would be hovering above or below the x-axis. So once again, if the discriminant is positive, there are two real solutions. If the discriminant is equal to 0, there's one real solution. And if the discriminant is negative, there are what are called no real solutions. Take that a little further, it's two imaginary solutions. It says, what is the number of real solutions of negative 2x squared minus 3x plus 5 equals 0? So we're just looking at what type and how many solutions there are. We're not solving this for x. All we're looking at is the discriminant. So take that negative 2x squared minus 3x plus 5 equals 0. Pick out a, b, and c. A is the coefficient of x squared. The number in front of the x squared is negative 2. B is the coefficient of x. The number in front of the x is negative 3. And c is the constant term, the number without a variable, that is 5. So a is negative 2, b is negative 3, and c is 5. All we're looking at here is the discriminant to tell what type and how many solutions there are. So if you take b squared, that is going to be negative 3 squared. Minus 4ac would be minus 4 times negative 2 times 5. Work through that. If you square negative 3, it's 9. If you take negative 4 times negative 2 times 5, watch your signs. It's positive 40 or plus 40. So 9 plus 40, that is 49. That means, since that is positive, since the discriminant is positive, there will be two real solutions. So the graph of that quadratic equation would hit the x-axis in two places, two real solutions. You can see that if you graph that quadratic equation, notice the coefficient of x squared is negative. That parabola opens downward. Also notice the y-intercept is the constant term, the number without a variable in standard form. That's 5. It's hitting the y-axis at 5. But what we're after here, what we're looking for is what type and how many solutions there are. Well, it's hitting the x-axis in 2 places because the discriminant is positive. If that discriminant is positive, you will have 2 real solutions, and that's what you're seeing there. It says how many real solutions does the equation 2x squared minus 3x plus 7 equals 0 have? So we're just going to look at the discriminant, tell what type and how many solutions there are. Is 2x squared minus 3x plus 7 going to pick out A, B, and C? A is the coefficient of x squared, that's 2. B is the coefficient of x, that is negative 3. And C is the constant term, the number without a variable, that is 7. So we're just looking at the discriminant, the part under the square root sign of the quadratic formula, b squared minus 4ac. So b squared, that would be negative 3 squared. Minus 4ac, it's minus 4 times 2 times 7. Keep working through that. If you square negative 3, it's 9. Negative 4 times 2 times 7, that is negative 56. And then 9 minus 56, that is negative 47. So your discriminant is negative. If the discriminant is negative, you will have no real solutions. In other words, you'll have 2 imaginary solutions. So when I graph this parabola will not hit the x-axis. It's going to hover above or below the x-axis. And since the coefficient of x squared is positive, that parabola will open upward. That means this graph will be hovering above the x-axis. As you can see there, the parabola hovers above the x-axis. It does not hit the x-axis. There are still solutions, but they're called imaginary solutions. There will be 2 imaginary solutions for x. Also notice the y-intercept is still there. The y-intercept is the constant term, the number without a variable in standard form, and the y-intercept is 7. So again, you can see since the discriminant was negative, there are no real solutions. That parabola does not hit the x-axis. You hit a golf ball into the air from a height of 1 inch above the ground. With an initial vertical velocity of 85 feet per second, the function h equals negative 16t squared plus 85t plus 1/12 models the height in feet of the ball at a time t in seconds. Will the ball reach a height of 115 feet? So we're not finding out when it will reach that, but if it will reach that height of 115 feet. So we're going to take that equation, and when we solve normal quadratic equations, we're substituting 0 for y, and that'll tell us where it hits the x-axis. In this case, we're going to substitute 115 in for h, and if we're going to solve this for t, that would be telling us when it hits a height of 115 feet, but we're not finding out when, but if. So we're going to get that 115 to the right side. Again, tough fractions to deal with here. I'll handle it. You just watch. I'm going to subtract 115 from each side. So 1/12 minus 115, that'd be negative 114 and 11/12. Now, all we're going to look at here is the discriminant. If that discriminant is positive, that means that golf ball would cross through the 115 mark. If that discriminant is 0, it just touched the 115 mark. And if that discriminant is negative, it's not going to reach that 115 mark. So we're just looking at the discriminant. Pick out A, B, and C. A is the coefficient of x squared, in this case t squared, that's negative 16. B is the coefficient of t, it's 85. And C is the constant term, the number without a variable, it's negative 114 and 11/12. The discriminant is what we're looking at, b squared minus 4ac. Again, this will tell us if that hits the 115 mark. Not when, but if. So if you take b squared minus 4ac, that is 85 squared minus 4 times negative 16 times negative 114 and 11/12. Put down the calculator, just watch, I'll handle it. 85 squared, that is 7225. Negative 4 times negative 16 times negative 114 and 11/12. That is negative 7,354 and 2/3. So if this is positive, it passes through the 115 mark. If it's 0, it touches the 115 mark. And if it's negative, it will not hit the 115 mark. You don't have to go any further. Look at those numbers. 7225 minus 7,354 and 2/3. That's going to be a negative number. Since that's a negative number, that's telling us the discriminant is negative. And that means there are no real solutions. So with that discriminant being negative, that means that golf ball, when you hit that, will fall short of that 115 mark. So imagine you're down here hitting this golf ball. It's going to be short of that 115 mark. That is the graph of that equation. When you graph that equation, imagine the t and the h would be replaced with an x and a y. If you graph that equation, it is not hitting the x-axis. In this case, if you graph this equation, it's not hitting that 115 mark. It's falling short of that axis.